We are going to learn how to predict products of single displacement reactions today. This is 7.3 Brascast. Before we get started, there are some tools you're going to need. You're going to need your periodic table. So take some time to find it. You're going to need your solubilities of ionic compounds table. And you're also going to need the activity series. So find your materials and let's get ready. Here's the activity series, and basically the activity series is set up so that the metals listed at the top are the most reactive. As we move down, they become less and less reactive. Therefore, lithium would be able to replace any of these chemicals, any of these metals. Potassium would be able to replace all of these except for lithium. If we're down here, copper would be able to replace any of the chemicals below or any of the metals below, but not those above, because these are more reactive. When you look at the halogens, it is the same idea. We can replace some of the halogens depending on their location on the chart. This is your new solubility chart. This is going to be very useful to you. And notice that any time that it says AQ, that means that it is dissolves, that this substance, this compound, for example, ammonium hydrogen carbonate, dissolves in water. And we can look down here, copper to bromide dissolves in water. If there's an S, that means that the solid does not dissolve. It forms a solid, therefore it is not soluble in water. If there is nothing on the chart, it does not exist. All right, so let us start with this reaction, one that you're already probably familiar with. Zinc plus hydrochloric acid. So I'm going to go ahead and write Zn plus hydrochloric acid, HCl, yields, and here I have already written the word equation for you, but we're going to look to see if zinc will actually replace the hydrogen, and we're going to find the location where zinc is. Zinc is right here, and hydrogen is here. Therefore, this reaction will take place because zinc is more reactive. Remember, this would be Kirk and this would be Joey in our previous example. So you're going to produce hydrogen plus zinc chloride. And of course, we would have to balance this equation. All right, our second example is sodium phosphate plus potassium. Will this reaction take place? Let's write the reactants. Sodium phosphate, PO4, -3 goes to sodium, Na3, PO4, sodium is +1, therefore it remains this way, plus potassium. Will sodium or will potassium be able to replace sodium? Potassium is here on the chart, indicating that it is much more reactive, and sodium is right here on the chart. So that means that potassium will be successful in replacing sodium. So this reaction will take place. And our product will be potassium phosphate, -3, K3PO4 plus sodium. So the single displacement reaction did take place. Our next reaction is silver plus aluminum nitrate. Let us write Ag plus aluminum nitrate, NO3, -1, +3, 3 yields. Will silver be able to replace aluminum? Is silver more reactive than aluminum? Let us find them on the chart. Here's aluminum, and silver is here. So indicating that aluminum is more reactive. Therefore, this reaction will not take place. And we will write no reaction. The thermite reaction is one of the most interesting and spectacular chemical reactions, at least single displacement reactions. It is a reaction that is used in pyrotechnia, which means that it is, pyrotechnia is the art of using and making fireworks. So it is a very important reaction. It is not explosive, which makes it an interesting reaction, but it releases great amounts of heat. The reaction is aluminum plus iron 3 oxide yields iron plus aluminum oxide plus heat. Because this reaction produces such large amounts of heat, it has several applications. In the civilian world, it has the application of welding in place. For example, tracks and axles of trains can be welded in place without, for example, having to remove the tracks because of the amount of heat. In the military world, there are thermite hand grenades, and also this type of reaction can be used to demolish landmarks or demolish certain equipment without making a lot of noise. In other words, when silence is important. I will insert a video clip here that shows you the Mythbusters and a thermite reaction that they took to extremes.
We're going to make some thermite. That means I'm going to take this and mix it with this and that, and we're going to cut that in half. Okay, that's nice and pretty, but we'll need a bit more detail. Thermite is a mix of iron oxide and finely powdered aluminum that burns at super hot temperatures. Used previously during the Hindenburg episode to pretty spectacular effect, as you can see. The Hindenburg had a paint job partly based on the key components of thermite, which at least contributed to this historic fireball. Thermite's also used to build bombs and in commercial demolition, so it's not the kind of thing you buy pre-packaged. So Jamie has to mix his own very, very carefully. The only people that we could find that are used to working with this kind of quantity of thermite normally make solid rocket boosters. And they told me that I need to be really careful with this because even mixing it in a mixer like this can generate enough heat from the friction that it could auto-ignite. And once this stuff goes off, you don't want to be around it. So we're keeping a close eye on it. Cue the sacrificial SUV. It's Adam's job to prep the patient.
I have to remove the tires because they don't want the tires to burn out here. So of all the things we're going to destroy, we're going to leave the burning molten rubber out of the equation and just set the car down on its frame. The first batch of backed up thermite is bagged and distributed.
So here we stuff these in around the engine, and when it starts to run through the hood, it'll settle off.
Now, Adam's method gives an insight into Jamie's madness. He's landscaping the car with house bricks to form a flaming gutter.
My vision is that we're going to create a river of thermite that's going to rain down on the inside of this SUV and cut it right in half. Now, is it going to do that? We don't have a clue. It hasn't been done before, but it's going to be cool.
That was just occurring to me.
What's that?
This is a freaking lot of thermite. Have you found anyone who's ever set off this much?
Nowhere close.
Cool.
Maybe somebody has, but I couldn't find it.
If he could, they probably wouldn't approve of this. By the time he's finished, Jamie's used more than 1,000 pounds of thermite.
It burns at 4,500 degrees. It's self-oxidizing, meaning that you can't really put it out because it doesn't care what you do to it. And as far as we know, nobody's used this much before. It's going to be amazing.
If this works the way we're planning, and actually achieve just splitting this SUV down the middle, then absolutely it's going to be better than a bank. But I really, it's anybody's guess as to whether or not it's going to work.
Wire up. Over.
Don't you just love seeing history in the making? Jamie sets the slow burn fuses. Then moseys on back to safety.
Personally, I'd take this over Bang any day because this is something special. Once this stuff goes off, it's going to be nuts. I think something's starting to happen towards the rear of the car.
Oh, cascading.
Yeah.
Oh, yeah.
That's what I'm talking about.
Well, it's coming out the windows. Steps are gotten into the cab. Burning thermite is 3 times hotter than molten lava, and the UV rays are so intense you can't view it up close without a welder's mask. No wonder Jamie thought this might be better than a bang. Ah! Oh, there it is. River's running down.
Yeah, you can see it dripping out the front of the car.
Exactly. Oh, that's great. As the fire peaks, then sputters, it looks like the thermite strip hasn't quite cleaved the roof. Looks like it's peeling out. Jamie decides it's safe enough to venture forth.
Well, it didn't really cleanly cut it right down the middle like I was hoping. There's not going to be a whole lot left of that car.
But rending the roof wasn't the main aim. They just want to know one thing.
Was this better than a bang? I'm sort of biased towards saying yes because, I mean, the amount of energy that was released here was just enormous. This was something that you just never see 1,000 pounds of thermite going off. This was fantastic. I loved it.
Is that an amazing exothermic reaction or what? See you tomorrow.